Respect level has gone down. So you're good on this one? Anybody else have a question on the homework? Lane.
29 on the
29.
On the actual.
For those of you who did not do this one, the question was, at what point on the graph of y equals 3 to the x plus 1 is the tangent line parallel to the line y equals 5x minus 1? Tangent line parallel to y equals 5x minus 1. Tangent line parallel. Interpret for me. If the tangent line is going to be parallel, the
Tangent line has a slope of 5.
we want the tangent line to have a slope of 5. Right? Because here's 5x minus 1. Here's 5x minus 1. And 3 to the x plus 1. Do you guys know what that graph looks like? 3 to the x. Think of e to the x. E is 2.718 to the x. 3 to the x plus 1. Right? So can you see the point? Can you kind of see it? The point where the slope of the tangent line is 5, the slope of this line? So it's where the derivative of this thing equals 5. Well, let's find the derivative of this thing. dy dx is a to the u times ln a times 1. Plus, what's the derivative of 1? 0. So we want the derivative, the instantaneous slope, to be 5. And you would need a calculator for that. If you wanted to solve it by hand, would you guys know how to? Divide by ln 3. Then what? What gets a variable out of the exponent? What kind?
logarithms.
A logarithm. What kind?
Stage 3.
Huh?
Stage 3. Is that what you mean?
That would work. You're saying convert this from exponential to log form using a base of 3. You could do that. You can log it with anything. All right? If you ln both sides, like you could do log base e. If you ln the left side, you have to ln the right side. You guys remember the properties of logs? If you have a log and there's an exponent, it can come down and multiply. Yes? And then divide. Beautiful, huh? That would be the x value where the slope on that is 5. Now, we would use a calculator. We would have used a calculator up probably at that point. Take out your dead calculators.
got two. We got two for a reason.
Use this calculator.
What do you guys think we should do? It's time next year to replace these, I think. But they're like $156 last time I checked. How many of you think either you or a family member would be willing to spend that on a calculator?
No shot.
I'm not asking you guys to spend it. I'm saying, like, if you were to come in day one and say, this is a calculator that would help you in this class, which I know you haven't, like, to be honest, you guys haven't seen that yet because we've been doing all the do it by hand rules. We haven't gotten into the calculator parts a whole lot yet. That's going to come next chapter. But knowing that, do you think your families would be willing to spend that or not?
If it goes into college too, then probably.
That's something we'd have to look into and talk. I'd probably talk to some local colleges and see if you're allowed to use it. I'd have to ask. All right, we're going to do a menu. We're in a calculator window. We're going to do a menu. Algebra. Solve. We're going to solve where 3 to the x equals what was it again?
3 to the x minus 1
Huh?
plus 5.
I forget. Oh, 5 equals 3 to the x ln 3, right? This is the point where we set the derivative equal to 5. That's what we want to solve. 5 equals 3 to the x ln 3. 3 to the x times ln's here. Control e to the x is ln 3. I said 3 equals 5. Now, it doesn't know what to solve for, so you have to tell it comma x with respect to x. So solve means there has to be an equation. We have an equation, comma x. Enter. And it's going to give you some ugly expression. All right, Control Enter will give you the decimal approximation. 1.379. Always round up 3 decimal places in here. So at x equals 1.379, please interpret. At x equals 1.379, the slope on the curve, or the slope of the tangent line, is 5, which makes it parallel to that black line. Make sense? Awesome. Other homework questions? All right, into logarithmic differentiation. Logarithmic differentiation. I would just write the heading, logarithmic differentiation. And we're going to make up our own rules here. Our own notes. Use when we don't have an appropriate rule. So this is what that means. You look at the equation you're asked to take the derivative of, and you say, I don't know you. You're not a power rule. You're not a chain rule. You're not an exponential e to the x rule. You're not an a to the u rule. You're not an ln of u rule. You're not a log base a of u rule. I don't recognize you at all. Oh no. I better use a logarithmic differentiation. For example, what if you saw y equals x to the x? Ooh. X to the 5th would be a power rule. 5 to the x would be a a to the u rule. But x to the x, there's no rule for that. Do you agree? Do you agree? So you say, I don't know that rule. Here's our first example. X to the cosine of x. I don't know that rule. It's not an x to a number. It's not a number to an x. It's an x to a function of x. Logarithmic differentiation. Do not confuse this with the derivative of a logarithm. Do not confuse this with the derivative of an ln or a logarithm if it's just the rules we learned yesterday. All right? All right, so I'm a little nervous because when I ln'd both sides in that last example to get the variable out of the exponent, I felt some confusion within the room. Was there? Do you remember writing from exponential to the log form and vice versa? Kind of? No? Do you remember by ln'ing both sides? Like I'm trying to think of a scenario where, like if you had e to the x equals 4, e to the x equals 4. Can you visualize what that looks like? Here's e to the x. At some point, it's going to hit 4. But how do you solve for x? Well, if I said 5x equals 4, you would divide both sides by 5. It's a different process, right? If I said x to the 4th equals 4, you would take the 4th root of both sides, because that gets rid of the 4th power, correct? You do the inverse operation to get x by itself. But what if x is in the exponent? What gets it down first? A logarithm. Okay, a logarithm. Let's do it. What if we ln e to the x, and then we ln 4? Do you agree I did it to both sides? I ln both sides. This is not this problem. This is like a little preview. You have to know how to do this for this to make any sense at all. Okay? What's ln of e to the x? I hear a right answer. I want to make sure everybody else is on the same page. ln of e to the x. I hear x. Do you agree? It's x. Did that accomplish what we wanted it to accomplish? What were we trying to do in this process? Solve for x. Did we accomplish that? Yes. Why? Because logarithms and exponentials are inverse operations of one another. Or they could be written in different forms. Well, if I did it to the left side, I had to do it to the right side, and I don't know what ln of 4 is. I know it's a little more than 1. I don't care, right? But what does that value mean? That's the value where e to the x equals 4. How did I accomplish that? ln'ing both sides. And ln takes an exponential function and, in general, brings the x out of the exponent. Specifically for an e to the x, it solves for x. What if it's, ready, new problem. What if it's 3 to the x equals 4? What if it's 3 to the x equals 4? What would you do to both sides? Let's ln both sides. Now what, Cole?
Take the x and the exponent and divide both sides by ln 3.
So wait a minute. This is now x times ln 3. ln'ing an exponential function brings the exponent out of the exponent. But what happened here? X times ln e, well, ln e is just 1. ln 3 is not 1. So now we have to do one more step to get x by itself. Do you remember doing this? I guess we're just have to move on at this point, I guess. I can't tell if you guys are confused or not. How do we get x by itself now? Divide by ln 3. ln 3 is a number. Divide by ln 3. We get ln of 4 over ln of 3. It's a value. That's your x value it's the x value where 3 to the x equals 4 on a graph. All right. Back to our story. We don't have a rule for this. X to the cosine x. There's no rule for it. Try the a to the u rule. It's not an a to the u. It's an x to a u. So we do a process called logarithmic differentiation. We're going to ln both sides. Yes, write this down. Are you guys good? Whenever you do the left side, you have to do the right side. All right, ln both sides. It is. Yeah, my smart board's kind of glitching. It's supposed to be. Where are the tabs? I know. It's gotten out of hand again. All right, ln of y. Agree, it's not ln times y, it's ln of y. Yes? What did that allow us to do over here? ln'ing both sides allowed the exponent to go down front, just like over here. So now I have cosine x times ln of x now you have to stop and say, do I have a rule for this? Because the whole point of doing this process was to get it into a form we have a rule for it. Can you take the derivative of ln of y? What is it? 1 over y times dy dx, right? Yes? We have a rule for that. Do we have a rule for cosine of x times ln x? Yes, a product rule. And within the product rule, we're going to have a cosine x derivative. Yeah, we're not going to have a chain rule in this one. We're going to have a cosine x derivative, and we're going to have an ln x derivative, and first derivative, second derivative, first, right? Product rule. But we have a rule for that. What's the purpose of doing this? To get it into a form that we have rules for it. Now, it's ugly, but it's the only option. All right? So, let's take the derivative of both sides. The derivative of ln of y, it's the ln of u rule. It's 1 over u, so 1 over y. Instead of du dx, it's dy dx. Right side, we got first times derivative of the second. Well, second times derivative of the first. Use parentheses. See why you got to know your rules. If you're stopping to flip all the time, and now I know we need to flip to look at our rules while we're doing tonight's homework because you just learned them yesterday. But a couple days from now, if you're flipping to look back at your trig derivative rules, that's an issue. That's why I had you guys take that Canvas quiz. Those have to be automatic, okay? Because it's going to trip you up if you don't know those ones, because then you're doing, okay, product rules, chain rules, all this kind of stuff with exponentials and ln's and, oh my goodness, with implicit derivatives. You guys agree this is an implicit derivative right here? That's why we had to learn it, okay? It gets messy. So you have to know these. All right, next step. I'm going to do two steps at one. What do I want to get? What am I trying to find here, by the way? dy dx. So I need to multiply both sides by y. So you're going to write y times all of this junk. We have, I'm going to rewrite this as a cosine of x over x minus an ln x times sine of x. Are you with me? Dom.
I suppose I have a y and not one of
Well, if it was 1/5, you'd multiply by 5,
the y. Okay.
right? It's 1 over y, multiply by y, it'll get rid of it. Both sides. Good so far? Now, I don't want y's in it if I don't have to. Implicit differentiation back in 3.7, there were some problems we had to leave y in it. We didn't know what y was to start with. In this problem, though, we know what y is. What is y? X to the cosine x. So that's your last step. And then we're going to write out a process to help you guys through this. So dy dx is x to the cosine x times, might as well make common denominators in here. It doesn't take much. Ready? X in the bottom, x up top, cosine x minus x ln x sine x over x. That is the derivative of x to the cosine x. It's a lot, I know. Okay? It's overwhelming at first. It's actually not that bad, and I'll show you how every single problem is going to be very similar. Okay? You've seen it once. Ready? Can we walk through a process? Step 1. What's step 1? Before that.
No.
I don't know this rule. Frustrated. Hands are in the air. I can see you guys doing your homework. I don't know what to do. The first step, I agree, you're gonna L both sides. But before that, step 1A. I don't have a rule for this. I thought through all the different processes. There's no rule for this. Because here's what's gonna happen. You're gonna start seeing derivative problems that you should know the rule for, and you haven't memorized it yet, and you're going to try this process on it, and it's going to be long and tedious, and you're still going to get the right answer. We'll talk about that later. This will work for any application. All right? I don't know a rule for that. I'm going to ln both sides. Lnning allows me to bring that exponent down. Now, wait a minute. All eyes up here. Every single time you're doing this to bring this function out of the exponent. And now that exponent gets multiplied times what? Is it always going to be ln of something? Yes, because you took the ln to get it out of the exponent. Let me say it again. You're always going to have the exponent come down and multiply times ln of whatever that was. Why? Because you did that. You took the ln of both sides to get that out of the exponent. So guess what's always going to happen? You're always going to have a product rule. Multiply, right? You're always going to have a product rule. And within that product rule is always going to be an ln rule. That's predictable. Do you agree? What's going to happen on the left side? You took the ln. It's always going to be ln of y. It's always going to be 1 over y times dy dx, because that's the derivative of ln of y. Okay, then what? Pattern here. product rule on the right. Are you always going to have to multiply by y? Yeah, because it was 1 over y, dy dx. Always multiply by y. And then last step, substitute y back in as a function of x. Does that make sense? Step 1, I don't know the rule. Step 2, ln both sides. Step 3, derivative of both sides. Product rule, ln rule. Step 4, multiply by y. Step 5, plug y as a function of x back in. All right, let's do x to the x, because I put that up there. Y equals x to the x. Step 1. Thank you. I appreciate that. I was looking for something. Thank you, Jackson. I don't know why I wrote dy dx, because I was talking. I'll try talking right. I don't know the rule. What should I do to both sides? ln. Because ln's get terms out of the exponent, right? I have ln of y. What does the right side allow me to do? It's the whole point of doing this. What comes down front? What is it? X. X comes down front times ln of what's left? X. X times ln x. Agreed? It's going to get uglier than beautiful. You take it from here. Uglier than beautiful. Like a caterpillar? Yeah. It's a caterpillar. It's in its chrysalis right now. He wants to be awkward now. He's looking at me longingly. He just wants back. Man, I wish I was doing logarithm differentiation. Yeah, that's the child's stuff.
Fractions. Multiplication tables or something.
Jackson. Did you do the paddle stroke? Jackson. I love Jackson. All right. X over X. 1. One plus ln x. Yes? What's the next step? Bye-bye. Multiply by y. I hate this thing. They get to be Thursday. CPUs are running high. Tabs are full. Thursday tabs. I'm just looking at it as it's helping me become a more patient person. just do it. No, it does not like logarithmic differentiation. Is that what you got?
Yep.
Not so bad, right? I'm curious to see what x to the x looks like. Are you guys curious? Oh yeah? You think so? Before I hit enter.
Put some money on it.
I have a question for you. What's f of 0?
Oh, that's like that big YouTube video. That the professor does it. Hey, the professor does it. He gets 1, and he gets 0. And then it's like 0 equals 1.
What the heck is
Yeah, it
that?
looks like exponential growth.
It's like every number it's not.
I've never seen a wonky graph.
That is the one.
Oh,
Whoa.
that's
That's a pretty nice shape right
Isn't it beautiful?
It looks like a Christmas tree.
It does.
It's like a Hershey kiss. Whoa.
So what's f of 0? Plug it in.
What's 0 to the 0?
Plug it in.
Yo,
That's gross.
What are you doing?
What do you mean?
back there.
Oh, that's the water fountain. There's no left side of the graph.
I'm distracted by the water fountain.
Not smart enough.
Yeah, that was calculated.
Why is it doing that?
That is literally a perfect Hershey kiss. That's how they probably got the Hershey kiss design.
That's crazy. I want to stop for just a second and think about. Let's evaluate like when x is -3. You have -3 to the -3rd. -3 to the -3rd. Isn't that 1 over -3 to the +3rd? Right? But what about -3 to the -5/2? No, sorry. I changed my mind midway. -5/2 to the -5/2. Changed my mind mid sentence. -5 to -5/2 to the -5/2. Isn't that 1 over -5/2 to the +5/2? But what's the issue? When you raise something to the 5/2, you raise it to the 5th, and then you square root it, right? You guys forget this already? Remember evaluating? Okay, what's 16 to the 5/2? Isn't it 16 to the 1/2 to the 5th, or 16 to the 5th to the 1/2? Isn't it either one of those? Because a power to a power, you multiply. What would you prefer? That one. Square root it first. Square root it first. What's the square root of 16? 4, and then you have 4 to the 5th, right? How about this guy? You square root the -5/2 first. Doesn't exist. Can't evaluate it. That's why it jumps at certain values. There's no output at certain values. And then it picks back up. Because -5/3 to the -5/3 is okay. You can take the cube root of a negative. See it? Bizarre. How do you write that? How would you write the domain for that?
Yes.
Whoa.
What's 0 to the 5th?
0.
0. 0 to the 4th. 0 to the 3rd. 0 to the 2nd. 0 to the 1st.
0 equals 1.
What's 2 to the 5th? 32. What's 2 to the 4th? What's 2 to the 3rd? What's 2 squared? What are we doing each time? What are we doing each time? Divide by 2. 2 to the 1st? 2 to the 0.
Doesn't exist.
You can't do that.
Divide by 0?
Zero's not real.
Zero's fake.
Zero's fake.
It doesn't exist.
Is anything real? Is anything real anymore? 2 to 0. Beautiful. All right. We did x to the x. I want to ask you this. Ooh, look at the thought bubbles. Thought bubbles. Gotta love it. And I'm not saying to do this. I'm saying what would happen if you're like, we know what the derivative is. A to the u times ln a times 1, right? That's the derivative. But what if you went by the way, quick little public service announcement. Don't start taking the derivative over here if you're still rewriting over here. This is a rewrite. Equivalent. If you took the derivative, you're a step ahead on one side and up. It's not equals anymore. Do you agree with that? If you're rewriting, keep the left side the same. 1 over y dy dx. What did I do? What's the derivative of x times ln 3? Good, ln 3. ln 3 is a number. 5x? What's the derivative of 5x? 10x? 10. 2x? ln 3x? ln 3. What if you did the product rule? First, derivative of the second, 0. Plus second, ln 3. Derivative of the first, 1. ln 3. Maybe you wouldn't have gotten it right. All right, boom, roasted. dy dx, y times ln 3, and what is y? 3 to the x, ln 3. Here's the skies. It wasn't it was an a to the u rule. But if you did logarithm differentiation, should you get it right? So, Mr. Westphal, if I'm on a quiz and I forget a rule, can I just do that? I guess. I won't be happy about it. Cole.
Anything else?
Can you do that to like derivative cosine x or something?
That wouldn't allow for you to bring down any exponent. It wouldn't gain you anything. But are you asking? See, 1 over cosine of x times.
I don't know, like he had trig values.
See, at that point, you would have forgotten. When you go to take the derivative of ln of cosine of x, you're going to have to do 1 over cosine of x times the derivative of cosine of x. And if you forgot the derivative of cosine of x, you would have not known the d dx in that either. Follow me? All right, your homework for tonight is to do the one you haven't done yet. And, well, you guys couldn't have done 43 and 40 whatever last night. How did you know how to do it? How'd you do it then?
I did it, it's just wrong.
Right, so you got to redo it.
But it's wrong time.
See what happens when you have a bad teacher? Yeah, they're there for everybody to see.
More.
They're growing.
So your last night's homework should have been 1 through 25 odd and 29. If you did not do that, do that one and then the 43, 44, 47. It doesn't take that long. It should not take that long.
Close the tab for every problem we have to do and see how many problems.
I'm not ready. Oh, Dom, I thought you were coming to see me.